Terraform has hundreds, not thousands of resources, and the docs, massive. You'll write 7 things, these things I'll go through it 80% of the time. Here they are in 10 minutes. You have resources, you got variable, you got output, you got module, you got for each, data source, state. Maybe the 3 extra functions you'll actually type out, and perhaps 4 to 5 CLI commands that cover day to day. That's it. Resources is the workhorse. Every line of Terraform that creates something in the cloud is a resource block. 3 things in the syntax: the provider type, like for example AWS S3 bucket, a local name that you choose, like maybe logs that are scoped to a certain module, and the body where you set the actual cloud configuration. That local name is how you reference the resources elsewhere in your code. For example, AWS underscore S3 underscore bucket dot logs dot ID, that would read the bucket's ID and feed it into another resource. That's how you wire your infrastructure together. Get that one pattern in your head and the rest just falls in. Variables are inputs to your module. There are 3 fields you will set maybe 90% of the time: type, default, and maybe validation. You always set a type, always, right? String, number, list of string, a map of string, object, and so on. Default makes the variable optional. No default, and the caller must provide a value. A validation now lets you reject bad inputs when using your right Terraform plan, not at apply time. 2-3 lines of validation could save you hours of debugging, even with AI. Now outputs, they let a module publish values back to the caller. Now the whole point of modules, this one word I want you to learn: composition. Output is how you let the parent module read what the child has created. If your module's output file is empty, your module isn't reusable. Now remember this one rule: document every output with a description, because when you actually start using it in the future, you will thank yourself. When you're trying to remember what is bucket underscore ID, then you have the module. Modules are how you reuse your infra code. Now there are 2 fields that are important modules: the source and the version. The source can be a local path, a git URL, a Terraform registry path, or even a private registry like Spacelift, for example. The version pins the module to a known release. You pin your versions always. A module that worked yesterday on a version maybe that's 5.0 can break tomorrow when 5.9 comes out with a breaking default, for example. So version equals 5.8.1, that exact pin could be breaking something else. Anything loose than that could cause problems. Now this is probably the strongest opinion in this video: use for each over count always. The count tracks resources by index. Now let's say you delete the user app, position 0. Every other user shifts down by 1, and now Terraform thinks every resource also unchanged. Now an applier could destroy and recreate them all. Now I've actually seen this happen in the real world. It's not fun. The benefit of for each is that it tracks resources by key. If you add or remove an entry and only that one resource is affected, the other resources stay exactly as they are. The only reason to ever use count is when you want 0 or 1, or one of something, right? The conditional pattern with count could sometimes equal var underscore create, that question mark, right? Where you see :0. For everything else, use for each. Then you have a data source. This essentially reads your existing infra that Terraform doesn't manage. So for example, if you need to look up a default VPC, a certain AMI version or the latest AMI, or even an existing IAM role created by someone else, the block is basically data, type, name, and you can reference it as a data, dot type, dot name, and dot attribute, and so on. Now, one rule that's important for you to understand is that data sources are read on every plan. Now, know this: heavy data sources could slow your plan down. So if you're querying 50 ES2 instances on every plan just to get one tag, that's not a good idea. Maybe put the value into a variable or another module's output instead. Then we have state. State is the file Terraform uses to map your code to the real resource in the cloud. If you lose this, you lose the link between the resource block and the actual S3 bucket in AWS, for example. Now Terraform thinks the bucket doesn't exist and it tries to create it. Appliers could get messy and so on. Now there are 2 settings that are important from the start. One is a remote backend. You never run a real code base with state on your laptop or someone's laptop. That's not a good idea. you might want to use an S3 plus a DynamoDB lock, or nowadays you have the native state locking on S3, right? If you're using things like Terraform Cloud, Spacelift, M0, all these things, they'll manage it for you. But make sure to pick a proper one and set it before you start writing your resources. And of course, the other one I mentioned before is the locking, right? You could use DynamoDB, but now you got the native state locking. Now, this is very important because it prevents two people from running apply at the same time, right? It actually comes from a software principle of locking, right? Shard locking and so on in Redis. Without it, two concurrent applies can corrupt your state and is much harder to recover from. Terraform has hundreds of built-in functions, and I'll give you 3 of them that cover 80% of what you ever write. Number 1, a lookup. This essentially reads a key from a map with a fallback default, right? And it's used every time you've got maybe per environment config in a map. 2, a merge. This essentially combines your maps. If you have 2 maps or more, you can combine them. The most common one is tagging. Common tags from a variable plus maybe resource tags, they can be merged into one map. And maps are better for your key conflicts, it always wins. And quite a common one, JSON encode. Now, this turns your HCL object into a JSON string and is commonly used for things like IAM policies, ECS task definitions, and essentially anywhere AWS wants to use JSON. Then you have a Terraform validate. This essentially checks your syntax and is good for type checking and is very cheap, right? There's no cloud code requires, and it's also good to have it in your CI pipelines. Then of course I have Terraform plan. This is the actual execution in CI or even locally. Run apply on a save plan file. And this is the thing that actually says, look, I want this created in the cloud and it'll create it for you. Now, I want to show you 2 mistakes that cause people a lot of Terraform pain. First one, having state on your laptop, especially in the real world, right? We've covered it. Make sure to have your remote backend set up. And 2, might be, uncommon, but unpinned providers and modules. Remember, anything that is, let's say you have the tilde greater than 5, if you have that, it's not ideal. Make sure to pin it to a certain version minimum. Make sure to use the exact pin. Now, if you take one thing from this, the things I mentioned, the 7 blocks, the 3 functions I mentioned, and the 5 commands, resource, variable, output, module, for each, data, state, the lookup, JSON encode, the merge, Terraform init, plan, apply, format, validate. This is 20% you'll use 80% of the time in Terraform. Everything else on Terraform is just docs and things you'll discover on your way out. If you want feedback on your Terraform module and your Terraform code, you can drop it in our free DevOps community in school. Check in the description below. It's free. I'll see you there. See you in the next one.